Hey guys, welcome back to Math Principles. Last time we were together, we were talking about factoring quadratics, and we went through a whole bunch of examples. Right now, what I want to do is take a look at some special cases. Now, remember, when we're factoring quadratic, the quadratic is of the form ax squared plus bx plus c, where a, b, and c are integers, and a is not 0. We talked about we factor out a GCF. Okay, we talked about what happens if c is positive or if c is negative. If c is positive, both of your factors, these two sets of parentheses, are going to have the same sign as bx. And we need to be able to add the outers and the inners to get that bx. If your c term is negative, one's going to be plus, one's going to be minus. The larger outer or inner gets the same sign as bx. So we don't know which one's plus or minus until we put these numbers in. And we need to be able to subtract our outers and our inners to get that bx. And we looked at a whole bunch of these examples. Okay, now all of these were pretty much the same format. We bring out a GCF, we factor what we can. What we're going to look at today is just a little bit different. Okay, if you look at this example, you'll notice there's no bx term. I just have x squared minus 9. Well, this doesn't really fit what we've been talking about because all of the factoring that we've done has looked at that bx. If c is positive or negative, if c is positive, both factors get the same sign as bx. If c is negative, one's plus, one's minus, but the larger one gets the same sign as bx. So what I need to do here, or what I can do to help myself, is add a bx term. Okay, I can add a 0x, because 0x would cancel and it would disappear. But I can use that as a placeholder to help me factor. And if I go ahead and factor, I know in order to get x squared, my factors have to start with x and x. Since my c term is negative, I know one of them is going to be plus and one of them is going to be minus. Now I've got to pick some numbers. Well, I can use 9 and 1, or I can use 3 and 3. Let's try 3 and 3. Okay, so if I sub in 3 and 3, on the outside I get 3x, on the inside I get 3x. Because my c term is negative, I need to be able to subtract these two and get bx. Well, 3x minus 3x does give me 0x. So those are the right numbers. They are in the right places. I just need to choose which one gets plus and which one gets minus. Well, the larger outer or inner gets the same sign as bx. Since these are exactly the same, it doesn't matter which one's positive and which one's negative. Typically, I like to put the plus first and the minus in the second quantity. So I have x plus 3, x minus 3. Now, if we think back to that very first day of these, okay, when we talked about foiling in the very first video, all the way back, here we go. Okay, we had an example kind of similar to this. Okay, x squared, x plus 5, x minus 5. And we saw that we ended up with x squared minus 25. Those bx terms canceled out. Now, that's going to be pretty consistent with what we're doing today. The exact same thing happened right here. Those three x's cancel, and I have 0x, which is just x squared minus 9. Now, guys, this is something called the difference of squares. And the difference of squares is when you have a squared minus b squared. If there is no bx term, we can be pretty sure for right now that we're going to be looking at a difference of squares. So I have x squared minus 9. Well, 9, I could treat that as 3 squared. And if we have a squared minus b squared, this has a special shortcut that we can use to factor it. It factors a plus b, a minus b. And take a look at what we have here. X squared minus 3 squared factors x plus 3, x minus 3. This is very consistent. This is going to happen for us every single time. Now, if we recognize this, we recognize what A is and what B is, we can jump to this factoring. But if we still need to, we can always put that 0x in place of the bx and factor using the chart. I'd like us to get in the habit of jumping straight to this answer. I think that's a lot more beneficial than having to go through all the extra steps. If you need the extra steps, they're there. I'd like us to try it this way for now. So I've got x squared minus 25. I notice that there is no bx term. B is equal to 0. If I recognize that, I'm going to try to see what I square for each of these terms. Well, a is equal to x, so I could say a squared minus b squared. My a squared in this expression is x squared. And my b squared in this situation is 25. Okay? Now, 25 I can write as 5 squared. If I can recognize this, I can jump straight ahead to that factoring, x plus 5, x minus 5. And we can be done a whole lot faster. Okay, take a look at number 11 here. X squared minus 16. Okay, recognize here that our a, what's getting squared to this, is x. And our b, what's getting squared here, is 4. And we can factor this, x plus 4, x minus 4. Now, what we're looking for when we're trying to determine if we have a difference of squares is that b is equal to 0. Remember our old quadratic, ax squared plus bx plus c. If this b is 0, all we have is ax squared plus c. And if c is negative, we're probably looking at the difference of squares. What's important to point out is that if c is positive, there is no way to factor the sum of squares. Okay, a squared plus c squared, there's no way to factor that. But if we have a squared minus b squared, that's something that we can factor quickly. So let's take a look at number 12 here. Okay, what am I squaring to get this 100? Well, if I take 10 squared, that gives me 100. What am I squaring to get x squared? We're squaring x. So this one will factor 10 plus x, 10 minus x. And there we go. Next up, I have 3x squared minus 12. Well, as always, look for a GCF if there is one. Okay, and the GCF here is 3. Sorry about that. Okay, if I bring out a GCF of 3, I'll have x squared minus 4. Okay, well, here we go, guys. In this case, our a is x, and our b is 2. 2 squared equals 4. So leave the 3 out front and factor it x plus 2, x minus 2. Okay, now the question that we always get is how do we recognize that it is the difference of squares? Well, like I said, guys, recognize that you have one thing squared minus another thing squared. There's no bx term. There cannot be a bx. It has to be missing. Your b has to be 0. So if you have one squared value, one perfect square minus another perfect square, you're looking at the difference of squares. The next question that we always get is how do we know what a and b are? Well, focus. What are you squaring to get that first thing? What are you squaring to get that second term? Well, x squared gives me x squared gives me x squared. 2 squared gives me 4. That's how we know what those values are going to be. Now, let's take a look at number 14 here. Okay, number 14, I see 4x squared minus 49. And I want to have a GCF. I want something that divides both of those terms, but there's nothing that divides both of those terms. Now, I still see this as the difference of squares. Okay, what am I squaring to get 4x squared? Well, to get that 4, I'm squaring 2, and to get x squared, I'm squaring x. And what am I squaring to get 49? Well, 7 squared gives me 49. So this is going to factor 2x plus 7, 2x minus 7. And there we go. So your a doesn't have to be simply x, or it doesn't have to be simply a constant either. It can be 2x, it can be 4x, it can be 12x. It can be anything as long as it's a perfect square. Okay, so next up, number 15 here. I have 64x squared minus 1. Okay, and I look for a GCF, but there's nothing that divides both of those. So I need to find what am I squaring to get each of these? Well, to get 64, you square 8. To get x squared, you square x. Now, what do we square to get 1? What times itself gives you 1? How about 1? So this factors 8x plus 1, 8x minus 1. And there we go. So if we're trying to factor a quadratic, and we recognize that there is no b term, okay? b is equal to 0, and c is negative. We recognize that we have a squared minus b squared. We can factor that a plus b, a minus b. If it's too difficult, okay, if you can't make this happen very quickly, you can always fall back on this approach. You can insert a 0x in place of that bx term and factor using the chart. Typically, that's going to take a little bit longer, but it will work. If you can recognize that you have the difference of squares, you can factor a whole lot more quickly.